In this problem, it says, based on a poll among adults who regret getting tattoos, 13% say that they were too young when they got their tattoos. Assume that 9 adults who regret getting tattoos are randomly selected. Find the indicated probability. So in part A, we want to find the probability that none of the selected adults say they were too young to get tattoos. So we're calculating the probability of exactly 0 people saying this. So because there's just one value here, we're going to use Binomial PDF. If it was a range of values, if it said 0 to 7 people said this, or if it said fewer than 4 people, something like that, we use the Binomial CDF function. But in this particular case, it's just the one value, so we use PDF. And you can get to there on your calculator by pressing second and vars, or variables. So we're using Binomial PDF. We're going to put in the number of trials, which was 9, right? 9 adults. The probability of an individual success is P, and that is 0.13. And now we want the number of successes that we're looking for, and that was 0. So when I put this into my calculator, I get 0.2855. So there's almost a 29% chance that that 0 people would say they were too young. And I'm going to write that down here on my number line. Oops. 55. So this is for 0 successes, and of course there could be 0 or 1 or 2 all the way up to 9 possible successes. In part B, we're going to do almost the same thing. Here we're finding the probability of exactly 1 success. So here I can use the Binomial PDF function again, and instead of being 0 successes, we're going to have 1 success. And that probability turns out to be 0.3840. So that's what we get for 1 success. So now in part C, it asks for the probability that the number of selected adults is 0 or 1. So that's going to be these two added together. And that gives me 0.6695. Now another way of calculating this, because now we're looking for the probability of a different number of success, not just one single number of successes, but a range of values. I could have done this also by calculating Binomial CDF 9.13, and 1 is the maximum number of successes. So that would be the probability of 0 to 1 success. So either way, I get that 0.6695. So now in the last part, it says if we randomly select 9 adults, is 1 a significantly low number? And we would say no, because the probability of getting anywhere from 0 to 1 success, so at most 1 successes, is greater than 0.05. So since this result turned out to be greater than 0.05, we would say, no, this is not a significantly low number of successes. So the low relates to this end of the number line. If we were looking at something being significantly high, we'd be looking at the opposite end of the number line. So if we wanted to know if 7 was a significantly high number of successes, I would be looking from 7 to 9. And we could calculate that in a similar fashion. So that's how you approach those problems.